This is my home-built process oven. Unfortunately, it's dead, so I have to make a new one. Now, I made this oven a couple of years ago and I did a video on it, so I'll make a link here so you can see the video. I covered all my design criteria back then. Unfortunately, it's died, and recently my wife's given me a new oven controller for my birthday. Now, seeing as one of the main uses of this oven was to do the burnout of investment castings, and I've done 2 out of 4 of the Beatles Abbey Road statues, I'm guessing that this might be a bit of a hint that I better get cracking and finish them. Now, if I'm going to do a new oven, I should probably first have a bit of a think about the things that I like and the things that I don't like about the old one. First up, the size. At 200 by 200 by 300 millimeters, I think it's big enough for most of the things I'd like to use it for. It can easily fit an A5 crucible, but this is, I think, an A10, and even that fits inside. I'm not convinced that I could melt a whole crucible of aluminium with an oven like this, but at least a smaller one it should be able to. It'd be kind of handy to do small aluminium castings inside. With the baby brother crucible, that should work fine. Now, one thing I don't like about this one, heat controller. I use this simple PID controller, and while it seems to work perfectly well, it's kind of annoying in that you've only got a single set point. So you can set one temperature, and while the thing was still working, it would quite happily control to that temperature. Most of the industrial processes I do, like burnout or heat treating, you need temperature ramps. So I need a more sophisticated controller so that I don't have to just babysit this by coming down every 10 minutes, increasing by 20 degrees, 20, 20, 20, letting it run for a couple of hours, then coming back, increasing, and doing the ramps manually, because that gets old real fast. Now, there are a couple of different options for doing a controller. I was kind of tempted to do like an ESP32 based roll your own controller, interfacing a K-type thermocouple for the temperature feedback through one of these little Max 6675 interface thingies. So that was one option. One of my very generous members, Alex, gave me the Siemens logo controller. The issue with this is I'm not sure how to interface a K-type thermocouple into it. It looked to me like I'd need some sort of quite expensive expansion module. But all that got solved anyway when my wife decided to give me this. So this is pretty much the same as the little PID controller I'm already using. It's just got a bit more functionality to it. So you can program in simple process ramps into it, which is pretty much all I need. The next thing I do like is the structural design. I like having the steel kind of external frame. The door closing mechanism spring-loaded, I'm really happy with that. I like that I put some thin galvanized steel sheet to protect the insulation. Huge negative is the insulation I used. This was just some leftover calcium silicate fiber board from an insulation job in the house, but it just basically turns to powder after a few heat cycles. I did try and reinforce it by giving it a hot face made of like water glass, sodium silicate, but because the substrate's not strong, the hot face also has no real strength to it. It just fractures and falls apart, hopeless. For the next one, I'll use aerated fire bricks, which should give the best balance between good insulative qualities, but also some mechanical strength. Next up, I like my door and its latch. Is this little spring-loaded bit which pulls up the door nicely while also opening smoothly, so I'll definitely be cutting those brackets off and welding them to any new oven. And the last part of that door mechanism, I've got this striker to activate the isolation switch, which turns off power to the windings as soon as you open the door, and that's to prevent electrocution. The way I did the coils was also not great. In case I was going to use this to melt aluminium for casting, I wanted a pretty high heat density, so I used 2 separate coils on 2 separate phases, because I've got 3-phase power here. Each side is 1 coil, 1 phase, but to get enough heat density, I ended up going for a pretty small diameter wire. This was 1mm diameter wire, and therefore it's not terribly robust. It burnt out quite badly on this side. Because I've only got a limited area in which to run the coils, I'm tempted on my next one to just do a single phase, run the coils across both sides, but use much thicker wire. That'll lead to a lower heat flux or lower heat density, but I'm not that convinced that I really needed that level of energy. I never tested it out to do a castings. I'll make it with a lower heat density, and if it doesn't have the energy for casting, it's not a big deal because I've still got a casting furnace out the back. I like this on-off switch. I recycled that from my Schalblin lathe. I guess one of the big things is I don't like the reliability, and that kind of ties in with its maintainability. I burnt out this coil when a part I was heat treating fell over and short-circuited against it. The thing with Cantel wire is it's quite ductile in its normal delivered state, but once it's been through one heat cycle, it becomes quite brittle, and trying to stretch this over to here to reconnect it, well, it just keeps breaking off. And the second coil, well, I think it was just lonely without its mate and committed suicide. But the dumb thing about my design was I first mounted the coils onto these side plates and installed them with some grout between the different parts. So there's really no easy way to remove these coils and install some new ones, even if the inside was more robust. Because coils are pretty much a consumable in a small oven like this, I think the next time I do it, I'll design it in such a way that the coils can be installed last, but also replaced quite easily. Right, so having gone through that, I can now go looking for a vendor for some insulated fire bricks, and once I know the dimensions of them, start designing a new oven around it. Mail time! This is the Cantel A wire which I ordered to make the heating element. Ah, cool. So this is going to be the back wheels for my oven stand. I've already got the front wheels. There's just a couple of casters I had left over from some other projects. Ho, ho, ho. It's present time. Guess these back packages were a little bit big for Santa to get down the chimney. Since they didn't fit under the tree, he put it in front of the other green thing in the house. Sodium silicate. This is good for making cores for castings. The cement for the bricks. The seal for around the door. Some insulation blanket and a bunch of bricks. Well insulated bricks. So thanks very much to Santa for all that. That's awesome. Right, let's get started by taking the bits I want off this one and recycling the rest. Now with the destruction complete, let me run through the design calculations for the new oven. So our power here in Austria is 230 volt AC, and we have a 16 amp household breaker. You can get nearly 4 kilowatts out of this. So I want a bit of margin, so I'm going to choose 12 amps. 230 volt through the 12 amps. With Ohm's law, we're going to need a resistance of 19 ohms. That's what our resistance wire is going to have to generate. I know what size furnace I want, and based on the bricks and stuff, I sort of did the design, and I came out with 215 by 220 by 340 deep. And that leads to a surface area of 3904 square centimeters. Is this power that I'm dumping in there going to be enough to power this size furnace? What sort of power am I going to get out of this? If I've got 19 ohms and 12 amps, power I squared R means I'm going to end up with about 2760 watts. So if I divide that by the area, and that returns about 0.71 watts per square centimeter of wall area. Now, I found a pretty interesting website out there. The guy done some comparisons, and it looks like the industry generally is looking for between 0.6 and 1 watts per centimetre squared. So we're in the green with that. Since I already did the calculations and I've already bought the wire, my wire is Cantal A, which is kind of the best you can get for this sort of thing. I think A1. And I bought 1.3 millimeter wire. I had to run through these calculations a few times to come up with this was my sweet spot. This is just a result of the whole thing. And that wire, when you look up in the catalog, that wire at 20 degrees has got a resistance of 1.2 ohms per meter. So how much wire are we going to need to create the resistance load we need? 19 divided by that is going to be an 18.73 meter length of wire. We now know how much power we're shoving through that length of wire. Can the wire survive it? For that we need to work out the surface area of that piece of wire. Surface area of a cylinder, it's a very long skinny cylinder, it's going to be pi d times length. So in this case, if I do it all in centimeters, we end up with 764 square centimeters of wire. And if we then divide our power by that number, in this case we end up with about 3.6 watts per square centimetre. Because I'm going to be sticking this wire into grooves, plus I'm going to be using a bang bang controller, which you should also derate it by maybe 20%. So this coil is going to be pretty much on the upper range of its power density of what it should be seeing, maybe slightly above. But hey, you've got to make some trade-offs somewhere. We've got our wire. We know how many meters of it we need. So what does that look like in terms of a coil? Your coil diameter, the catalog's given you values of big D coil diameter to little d wire diameter, 6 to 12. So in this case, I've chosen a 10 millimeter mandrel. Big D 10 divided by our 1.3 wire. That's going to give us 7.7. which is between 6 and 12, so that's also okay. How many windings do we need? 527 turns of wire. Now, because I already know the size oven that I want, there's not a lot of different options of how I'm going to run this stuff. Basically, the idea is I come out through a back wall, go along the side, down, back, across the back, along the side, and return. And I can get about 30 centimeters per side, 20 in the middle, and that works out at roughly 190 centimeters of coil that I need. Now we have to stretch the winding out, because if you left it just tightly wrapped, then it would just short circuit. What's our stretched length? So once we stretch that coil across there, we're going to end up with 2.77 is like the thread pitch. Rather than those wire being tightly wrapped, we're pulling it out about 2.77 thicknesses of wire between windings. And that's another thing that's given to us by the catalog, and they say you want to be between 2 to 3. So that's also good. All in all, this should end up with a reasonably typical sort of layout. I'm hitting the wire slightly harder than I should. I'm on the lower side of average for the power density. It's all pretty normal for what an oven should be. Right, for this new oven, I'm using these high-speed fire bricks. They're rated for 1400 RPM. You can sort of get them in 3 different styles, 14, 16, or 18, I think. As they get more refractory or more fireproof, they also become more dense, so they don't insulate as well. This seems to be the sweet spot from what I've read on the internet. Now to make the sides, I'm going to use 3 high, 1 across, and 1 half. So let's chop out that half. Now one time when my dad was here, he needed to cut some bit of wood, and he grabbed this saw, and man, it took him forever to cut through that wood. You know, it's a shame he didn't have a son to tell him that the decent one was right next to it. Yeah, this saw was already used to cut the aerated cement blocks to make a wall. Okay, need to be more careful at the end of my cuts. Right, I don't know why I need this many different spatulas. So the mortar comes from the same outfit as the bricks. Settled out a little bit, but not too much by the looks of it. Give it a good stir. The moisture sure sucks out fast. Right, for the other wall, I think I'll try strap clamping it, see if that works any better or any worse than the other type. Next up, 3 bricks together for ceiling and same for floor. Right, this is now going to be the back wall of the oven. Those have now dried overnight. Right, it's mask on for the next part of this operation. Right, next up, I need to cut the rebate or rabbet or whatever you want to call it, so that the sides stick down slightly and get sort of mechanically locked in place. Since the next step of the operation is routing, the logical thing to use would be my router. It's even got a nice little side guide thing to run along the edge of the bricks and stuff. However, I really don't think it's a great solution for this because this has no speed control, so it only runs at full speed the whole time. And I'm not really interested in blasting all that silicate dust as hard as that would do it. So what I think I'm going to use, right, to be able to use this as a router, I'm going to need to extend the table a bit. With those 3 cutters, I should be able to cut out the various slots for the heating elements and other features necessary into those bricks. Mask on. Oh. I mortared these bricks together yesterday evening before I went to bed, so it's probably only 10 hours ago or so from now, and this mortar's not set yet. The one thing I did do differently was I wet these bricks before putting the mortar on, figuring that it might stop the mortar from sucking up dry quite as quickly, and therefore giving me a little more time to do the setup, and maybe that's the problem. It needs more time to dry anyway. These stones abrade so easily that it's quite useful. You can just use one stone against the other to sort of grind in the fit of a pair of matching stones. Yeah, that'll fit nicely. Right, so now I can lay out my groovy pattern on the 2 sides. Before I start routing the slots for those coils, I think I'm going to make the coils so I've got something to compare. Let's make up the winding jig. Now it's really important that this be done with green painted wood. Now 10mm hole through the whole thing. And then this piece needs clearancing for the mandrel plus 2 bits of wire, so it'll be 1/2 inch. Now we need a tangential groove for the wire to feed in through, and a mandrel with a slot or a hole in the end of it. Just throw a bit of wax on there. Right, I'll first get it started and then start working out how to control the rest of the wire. It's coming in nicely. Oh bugger. If I'm going to lay 527 pieces of 1.3mm wire next to each other, the total length of the mandrel is going to need to be, at the very minimum, 527 times 1.3 plus this much. And that ain't it. So I guess what I'm going to have to do is loosen this off. Slide the wire off its... off the slot. Luckily I slotted that end, and then move down a fair ways. Pick some spot and stretch the wire. Click that into the slotted end, and then be very, very careful from here on in that I don't have this floppy bit making a big knot. When I install it, I'll have to make that into sort of a corner or something and try and halfway massage it back into a nice evenly looking piece of wire, and yeah, go from there. That is going to work. So that was 300 windings there. Let's count on. $400. Yep, 100 is exactly 13 centimeters. Who would have guessed? Another 30 to go. Right, that's my 527. And now you do need the mandrel to get it off. Luckily I've got enough wire to make two, because I wanted to make a spare. You sort of have to unscrew the last of the coil from out of the wood. Right, bit of massaging to get this back into shape. Now we need to stretch this out. So it's going to stretch out to 190 centimeters. Still tweak that on installation. The most important parameter here is what's the resistance? 18.9 ohms, and our target was 19. All right. Right, had that been a real failure, I'll probably go and buy another bar, 1 meter long, to use as a mandrel, but it makes such little difference. You need stretch corners and stuff anyway, that I'll just make the second one as a spare. Now, looking at the marks in that piece of wood, I don't think you even need to make a groove for the wire to follow. It'll just find its own groove. Now, the coils get terminated outside the oven in these ceramic high temperature terminal blocks. To reduce the amount of heat on the extension lead, I'm going to treble it up, which will lower the resistance and therefore lower the heating on this part of the coil. And I already checked it, and a treble twist of this does fit through my terminal block. These are Lockwire pliers. They're used for safety wiring bolts and nuts and stuff on aircraft. They're kind of cool because they have a twisting mechanism in there, but unfortunately it's not strong enough for this very thick wire. So I have to twist by hand. They do have this nice little latch to them. And with that, there's the finished coil and the spare. Actually, I'm kind of tempted to mount the spare coil somewhere in the back of the oven so that I don't lose it. Because if I need this in 5 years' time, I'll probably forget I even made it. I'll switch bits for the slotting of the coil grooves. These get done in two parts. First going through with a T-slot cutter. Right, you can see those T-slots which I've cut are going to be too shallow for the spirals to go in. So next up we open them up with this cutter here. I might also have to just widen those slots just a little bit. They're probably still a bit narrow. Oh yeah, that fits in nicely. A couple of years ago, a kind viewer from Canada sent me this. It's a high temperature coating for furnaces and ovens and stuff. I've already used it on my main furnace. I'm pretty sure it's like a zirconia based product, so it just reflects the heat back in rather than absorbing it into the bricks. So I'll use the rest of it to give this a coating. Well, one of the big mistakes I made on my first oven was it simply wasn't maintainable. I kind of assembled it with the heating element going in during final assembly, and then there was no way to actually maintain it. There was no way I could get back and change out a heating element without destroying the whole thing. So this is going to be a dry run to see whether I can install the heating element in the final oven, and therefore whether I can replace the heating element if it burns out. Especially getting around the corners is the biggest challenge. I need to run the entire 2-meter spring all going in from this one point. My guess is by the end of it, it's going to be a pretty slow process to massage it around, but hey, slow's okay as long as it'll actually work. Okay, so that's not the easiest thing in the world to do, but it does work, so that's really good news. Right, the last thing I still need to do before I assemble this is just put the holes in for the coils to enter and exit. I took a drill out of my needs to be sharpened pile. Now I'm kind of guessing this is going to get kind of hectic, but right, with this now bricked up, I can start turning my attention to the metalwork. These insulating bricks are 65 millimeters across, which is probably on the low side for the insulation anyway. But once I cut those deep channels for the heating elements, I'm left with only maybe 40 millimeters, bit under 2 inches of insulation. And that's why I bought some insulation blankets to go around the thing. But that then complicates the ironwork a little. So mostly I'm going to make the frame out of this 20 by 20 angle iron. But of course here at the front, I can't make enough lip for the insulation, so I'll use a piece of 40 by 40. I'm going to need a whole bunch of mitering cuts, but unfortunately I don't own the dual miter adapter which runs on this rail. So in absence of that, I'll just put the rail back off and bodge up my own version of a mitering adapter. Right, I'll just make a mark where I need to clearance it. So with that now pivoting, I'll just set that as close as I can get it with the probably not very accurate woodworking angle gauge, bevel, whatever you want to call it. tape it there. And then I'll just do a couple of test cuts in wood to make sure that does actually cut 45 degrees. So how does this look? With a decent square. Okay, it's not too bad, but it's still a little bit off there. So we're cutting to acute. Right, I'm set up now to do the first tack welds on that first bit of frame. I'm in the affiliate program for Arc Captain, so if you like a welder like this, I'll leave a link below. There'll be a discount for you, and they'll kick back a couple of % for me, so I'd appreciate that, and they're a good welder. So what are we on? We're on DC TIG, 2-touch because I've got the foot switch on, pulse off, and I'm going to want probably, I guess, 90 amps or so. Let's see what that's like for tacking. Now the most important thing to me on this front panel is that it ends up flat, because that's what the door's going to close against. I've already cleaned everything with acetone, including my filler wire. I haven't done this for a while. I thought I was getting a bit of carbon here. It's only 6 litres per minute. I'll up that to about 10 or so. Whoops, I dipped the tungsten on that set. All right, no rock. Hey, while we're on the topic of grinding discs, have any of you ever used these 3M Cubitron 3 grinding discs? Stefan Gotteswinter made a recommendation on them on one of the German forums, and there was a special on Amazon a while ago, so I bought a package of them. They're quite expensive, but man, they last forever. Like before this, I just used sort of cheap and nasty no-brand ones, which cost probably a buck a disc or so, and these are probably 5 times as expensive, but they seem to last 10 times as long. So a big thanks to Stefan for that recommendation. Okay, with the front bit done, Well, I think my welding's slowly improving. But for cosmetic reasons, on this job, those welds are getting ground off anyway. I've already marked this out. Because this is 18 millimeters bigger all around, I can rebate it into the brick a little bit so that the whole thing ends up flush. Maybe the thing most resistant to the abrasive charms of this brick would be this carbide scraper. These kinds of bricks really are easy to work with. Okay, that looks good. Right, now I'm going to need to flip this thing over so that I can sort out the little standoffs to support the brickwork against this. So here you can see the idea. I'll weld in just supporting corners here just to add a bit of support to the brickwork, and then there'll be insulation blanket stuffed down in between there, and then another layer of steel on the outside. I'm hoping that'll be enough just to give the brickwork a bit of location and support. Let me go and weld that. Okay, those are just tacked on so far. Nice. The back needs to be spaced back enough for the insulation, so I've got that up on a block there, and I'll be doing the same sort of thing again. I'm just spacing this up on this 18 millimeter block of wood. I'll get it nice and even all around, and then I can start cutting these pieces, which are going to support the sides. Right now I could just weld this up like that, but once again I do want some maintainability of this furnace. This will be welded on the front portion here, but here I'm going to put in a bolted joint. So for that I'm going to need some barrel nuts. Join me at the lathe. Any old scungy steel is going to be good enough for this job. Main thing, it needs to be weldable. I'm always impressed by this lathe's ability to find nice shiny steel, even the most scungy old pieces. I mean, this was just a rough and cut, but wow. I keep forgetting to hook up a spindle brake, because there is one installed on this lathe. And if I had the spindle brake installed, I could use one of these clutching tap holders to do automatic tapping. As long as I don't have the spindle brake, the thing runs on too long, so it's on the board. Right, now rinse and repeat that 3 more times. I think I'm now ready to weld in these spreaders. Okay, I've made a bit of a pickle for myself here. I shouldn't have welded the brick support angles in till I'd welded those fixed nuts in place, because now I can't really get down there with the TIG torch, but that's okay because that's why you have a multi-process welder. So let's switch to stick. So I just looked it up and I need electrode positive, so this is my ground clamp. It'll switch over to here. Here's the electrode holder. No, I'm using 1/8 inch 6011s if I remember rightly. Nice and old, not dried out properly. Enough of that drama, let's go back to TIG. Well, I really am enjoying playing around with the TIG welder, that's for sure. But I'm still going to grind them off. Right, well, with that main section of frame pretty much finished, I'm at that point where a whole bunch of different jobs sort of come together and they all need to be done at the same time, but they're all interdependent on each other. For example, installing the brickwork, insulating it, putting on side panels. As soon as I put the brickwork in, the whole thing's going to get heavy as hell. One of my design goals was to put this thing onto a stand, put it on wheels. So I think that this is a good point to chop up some of this leftover steel tube which I've got from another job and make up a stand for it so that as soon as the brickwork goes in I can still move it around easily. To make sure I get all of my spreaders the same size, I've just put a little stop on the end there. This is the material for the stand. Not sure what happened to the audio there. I didn't bother filming the welding of the stand because it's more of the same. Right, I'd now like to get this off this wheelie stand and get it on its own wheels. I do have 2 of the casters left over, which I've used on a couple of other projects, so they can be the front wheels. Where these casters are going to need something to bolt to, and I've got a bit of steel here that's just about the right size, so that's nice. Kind of helps to put an earth on things. Where does that bottom of that wheel end up? About 71 centimeters. So now I need to get this one down the same. Ah. Right, now I'm going to drill all the holes in the control panel. Now I think that the next task I'm going to do is to insulate the sides and put sheet metal over them. This is a high temperature insulative material, which is also biologically compatible or something, so it doesn't get into your lungs like silicates would. I mean, I'll still wear a mask with it. It turned out to be cheaper just to buy these shelves than to buy sheet metal as is, so I'll have to just chop these edges off a bit and get insulating. Now I've got the pieces of sheet metal cut. Let's try getting a piece of this stuff into there. As is often the case with my projects, I made everything too tight, not enough clearance, and it was really quite a pain to get this insulation pushed all the way down. Now I needed a way to mount my temperature probe in the back of the oven, and also where these wires come out I need to mount the ceramic connectors to wire it into the rest of the system. So I've made up this little bit, which I'm hoping should do a nice job of it. I'll weld this in at both ends here, and that also provides the strap which prevents this whole brick assembly from moving backwards in the metal. I really do struggle with these like closed off corners with not very good access. Really struggle to get decent weld. I think I've got a tack in there. Right, it's time to massage this back into place. Might take a while. Right, well that's where I left off yesterday. As you can see, the heating element's in. I'm not super happy with the way it's going around the corner there. I really couldn't get it to sit better into the corner than that. I think I'll work on the door. So the brickwork's all finished with its coating on it, and I routed the edge for the angle iron. So now I just need to cut out angle and weld it up. Now I just need to miter them. Right, so to protect the door's brickwork, I've now got this frame done. And of course, I also need something on the other side. A bit of sheet metal, a couple of standoffs, and some insulation under there, and the door will be done. Right, so I've whipped up 4 corner biddies on the bandsaw. I'll take them on one side, probably this side I guess, and then pull it apart, put in a final strip of sheet metal to protect the brick on the sides, and then glue it all together. So now I can start putting the hardware on the door. This is the striker for the micro switch, which turns the power off whenever the door's opened. Right, my plan was that this was all going to be my Christmas project. You know, for those days off between Christmas and New Year, I'd quickly make this oven. Well, it's now the 31st of January, Friday, and it's still not finished. I've still got quite a bit of work to do, and I better get cracking to get this done in time to have a video up on Sunday. So I still need to make the hinges, still need to make the second half of the door latch, mount things like the door micro switch, and do all of the electrics. So it looks like I better get cracking. At the moment, this lid has been sitting on just an old offcut of insulating cord. I got some new stuff for this project. I need to know exactly where the door's going to sit before I can finalize the hinge position. So now is the time to cut the groove for the insulating cord and glue it in. Right, I hope this stuff still works. It's not the newest tube in the world, but it is still liquid. You know, when I get some time, I really need to do some practice on inside corners, because they're always ugly as. Alright, I'm down to the last task before I can paint all of this bare frame, and that is to put in the 2 screw holes to mount the micro switch. I bought some barbecue high temperature spray. Right, somewhere along the line I also painted the stand, and while I was doing it, the faceplate of the control panel as well. Now with that yellow I ended up with a terrible texture, but it ended up kind of even, so I'll just call that a feature and say I meant to do it like that. I think the paint was like really old, or I don't know. This solid state relay I'm going to use to control the heater coil on and off. Generates a fair bit of heat, so it's going to need a heatsink. I've got this one I took off the old machine, but I need to cut it down to size. Well, I reckon parts of this job are going to be an audio nightmare. I'm going to have to cut down the edges of these a bit, and they're going to sing like crazy. The main thing is I need to just clean up around the bottom and cut the edges and stuff. I had no real feel for what depths of cut and feeds and speeds would work with that horrible stick out, so I just did it manually. Since the electrics are going to go in here underneath the oven, I'm going to need some sort of a sheet metal protector tray thing there. Well, I haven't used this for a while. It's dusty as. Rusty too. Probably put some preservation on it next time before I put it away. I can't get it out. Oh, just pop off those fingers. Right, I just threw a couple of screws in from the bottom to hold the tray in place, so now I can do final electrical assembly. I bought this cable for it. I'll have to chop off the other end, and I got this one because it is rated for 3.5 kilowatts. I've got everything wired up now, up to the solid state relay. So let's plug it in and make sure it's all working before I put the big heavy oven on it. Okay, that's a good sign. Okay, that definitely heated up, but there was no change. Okay, I'd wired the thermocouple wrong. I misunderstood the manual there, but now it seems to be working. Next up, I want to program this light. It's going to be a oven is hot light. So I've mounted the heatsink and mounted the solid state relay. Now I'll just do a little tidying up of the wiring. Right, while I'm also in here, I'll just set up a couple of supports so I can put in my spare coil and also the spare cord for insulating the door, and I'll just lock them down so they don't rummage around. I'm using this light here to simulate the oven, but being an LED light, even the bleed voltage or whatever through the solid state relay is enough to make it look like it's on. It's not. I was a bit confused because when I hit run, only output 2 goes on, output 1 doesn't, which is the output I'm using. Nothing changed over here, even if I closed the door. But a bit of internet searching showed that this device has to have an external run switch. It seems starting this machine from the front panel only puts it in hold mode, not in run mode. So I need a separate run switch. Plus, there's no way to stop it from the panel, so you need a stop switch. And it seems this is the light version of this controller maybe. The alarm function may not be programmable as I want it. So what I'm going to do, I'll remove my alarm button and replace it with a 2-position switch that gives me a start and a stop, and will fit in there. Waiting for that output 1 to go on. Once I get the thing connected, I'm still going to have to do some sort of PID tuning, I guess. Ah, look, there it goes on there. That's good. And then to turn it off. Off. Okay, I think I've got this electrically as far as I can test it here. So it's time to put the oven on it and connect it all up. It's about time we try this thing out. So I think I've got it set for 200 degrees. I've done nothing to set its PID tuning, but let's just see what it does out of the box. If we look at the whatever the MV is, it seems to go up nearly to 100% before it switches on the output. I mean, these are all parameters I'm going to have to go through and work out how to set it all up properly and how to do the PID tuning. Let's just see what happens. So it's now gone on. Hopefully soon we'll start seeing some temperature rise on the green sensor. I am a bit concerned that the sensor doesn't stick far enough out into the oven, and therefore it may be very, very slow to sense temperature changes. Okay. I'll bring you back once it's heated up. Okay, it's taken quite a while to heat up to display 200 degrees, but once again I think that's probably more my thermocouple's too short. Well, one thing that's interesting, it hasn't switched off. So if we look at the set point's 212, so 213, why is that changing? I guess it's at this point that I'd point out that this manual looks really good, but is kind of garbage. My controller doesn't have all of the parameters it's supposed to have according to this, and a lot of the stuff's just not understandable. I need to learn how to program this. I haven't really put much effort into it yet. The only thing I'm interested in right now is whether in this mode it will actually shut off when it reaches a set value, but if that set value keeps changing, let's take a look inside it. There's plenty of heat there, that's for sure. This is much slower to heat up than my old oven was, but I guess that was to be expected because the old oven had nearly twice the power and better insulation and was smaller, which is probably also the reason why it burnt out so fast. So there's obviously significant lag there because this interior is definitely way hotter than 250 degrees. I've just ordered a new thermocouple, much longer. I'm now just starting to feel the first temperature rise on the outside. It's only a few degrees, but it's starting to feel a little warmer. The frame's still cold. You don't feel any heat radiating out around the door, which is good. So I think that seal's good. But since we got one of these inline power meter things, let's see what sort of power this actually draws. Doesn't go beyond 400. That would be a problem. Maybe that's a limit that I need to go in and reset. Right, with it now powering up, you can see that it's pulling a little less power than I would have hoped. 2.3 kilowatt, I was aiming for more like 2.7. Guess we'll see how that works in practice. I mean, I could pull the coil out, shorten the second coil, and plop that in for a higher rating, but we'll see how I go with just 2.4 kilowatts, see if it works for me. Well, I think it's time to call this build finished and go and edit this video. Obviously, once I start using it, I'll have to learn the programming to it. This has really been quite a monster project. I did not expect it to take this long or to be such a huge video. I'm pushing 3/4 of a terabyte of video files to try and wade through, so it might take me a while to get this one edited. If any of you are interested in that sort of thing, the final tally on the TIG welding was 10 dipped tips. But once again, thanks a lot for watching. I'll see you next time.